This video is pages 1 and 2 of the Chapter 4 notes. In Chapter 4, we also include 2 lessons from Chapter 1, 1.6 and 1.7, and that's what we are discussing in today's video. In Lesson 1.6, we have a lot of vocabulary relating to the term function. So when we have a function consists of a set called the domain containing numbers called inputs. It is also called the independent variable. And often the variable x is used. Function also consists of a set of numbers called the range, containing the numbers that are the outputs, and is also called the dependent variable. And we usually use the variable y. For a pairing to be considered a function, each input must be paired with exactly one output. So in this first example, we have a table of values with inputs and outputs, and we're going to identify the domain and range. So we know the domain is our inputs. We're going to write them in set notation, so we use these curly brackets saying this set of numbers that includes 0, 1, 2, and 4. And our range is our output values. And although we have repeating a value of 2, we don't have to write it twice in our set. And usually we write them in numerical order. So our range is the set of numbers 1, 2, and 5. We can take that same information and make it into a mapping diagram. So we have our input values, 0, 1, 2, and 4. We have our output values, 1, 2, and 5. And then we draw arrows to match each input with its corresponding output. So 0 and 5, 1 to 2. 2 also goes to 2, and 4 to 1. So looking at the definition, to be considered a function, each input is paired with exactly one output. So although these 2 inputs go to the same output, we don't have any inputs that go to more than one output. So this is a function. Now we're going to look at these 3 examples and determine whether these pairings are a function. So looking at this one, I see that this input 3 has 2 different outputs. Therefore, this one is not a function. In this mapping diagram, I see that each input goes to only one output. Therefore, this one is a function. And in this last table, I see that each input happens to go to the same output, but because there are no repeated input values, this one is also a function. Another way to determine whether a relation is a function is to look at its graph. If you draw a vertical line through the graph of a function, or of a relation, and cannot cross through the graph more than once with any vertical line, then it is a function. Okay, so looking at this relation, there is nowhere on this graph where I could draw a vertical line that would cause the line to cross through the graph more than once, meaning there are no repeated x values. So this one is a function. This one as well, I could draw a vertical line anywhere on the graph and not cross the graph more than once. Therefore, it is a function because there are no repeated x values. Now on this relation, I see that a vertical line is drawn through 3 separate points in this relation. Therefore, this one is not a function. So we can see that although we don't know what those x values are, we can see that those are repeated x's. So by drawing the vertical line, using the vertical line test, we've determined it is not a function.